I am Alexandros Bakas from the Network System and Security Research Group at Nokia Bell Labs Core Research, and I will be presenting to you the paper Authenticating Mobile Users to Public Internet Commodity Services Using SIM Technology that I co-authored along with my colleague Siddharth. So a few background information. So what are the SIM cards? They are smart cards that typically link an account to a certain device. SIM cards are the device's gateway to the cellular network, and they store various data such as the identity of the subscriber, the phone number, the IMSI, authentication keys, contact list, so on and so forth. And the network authorization data is the component that allows a mobile network operator, or MNO, to authenticate a user's request to access the network. So probably you have seen a similar slide before. SIM cards began as physical and very big, with a trend to become smaller and smaller. These physical SIMs have various shortcomings. For example, a physical SIM card is bound to a single subscription data over its lifetime, and the installation of the subscription data on the SIM cards need to be performed physically by the operators. So people came up with alternatives to physical SIMs. That is the embedded SIM, which is which is embedded on the mobile device upon manufacturing, but it's still a different processor on the device. And then we have iSIM, which is it's not a cloud component. I just want to highlight that it's managed through the cloud, which is embedded directly on the SoC of the device, leaving up space for the design of the devices. So what happens inside the eSIM, iSIM, or EUICC? I know it's not exactly the same, but in this presentation I use the terms eSIM, iSIM, and EUICC interchangeably. So this is a very high level and simplified slide. Many components are missing, only focusing on the ones that we care about. So we have the ISDR, which is a representative of the EUICC to the network. So ISDR is the guy that communicates with the network. We have the ISDPs, which are different profiles, so each operator can have a different profile on the EUICC. And then we have the ECA ASD, which is a key vault in which the authentication keys are stored. So the way to download profiles on an eSIM is through the remote SIM provisioning protocol. We have two different variants, the machine-to-machine solution, by which we can provide thousands or millions and billions of IoT devices with new profiles and new subscription data on the fly. And then we have the consumer solution that just makes the life of a consumer easier by not being forced to go to a store to change subscription. So now we're focusing on the consumer solution in this presentation. And before I dive in, I would like also to give a very simplified description of how RSP, the consumer solution, works. So we have a mobile network operator, MNO. We have the SMDP Plus component, subscription manager and data preparation. In the machine-to-machine solution, this component is divided into two components, SMDP and SMSR for secure routing, but in the consumer solution, these components are merged into one. So the flow here is that the MNO sends a profile ordering request to SMDP Plus, where the SMDP Plus will then send a create ISDP query to the EUICC, or if you want, allocate some memory on the EUICC for the creation of a profile. As a next step, the SMDP Plus component and the EUICC will establish a shared secret key, and then the profile will be prepared and sent over to the EUICC secured with a key that was established in the previous step. So a few observations and motivations for this work. First of all, it is our belief that eSIM and iSIM technology is very powerful, but it's underutilized at the moment, since its main functionality is limited to provide network authentication and connectivity. For existing authentication solutions, we have solutions such as GBA, BEST, or 5G ACMA that use the same identifiers and credentials for MNOs and non-MNO services. And then, to the best of our knowledge, most of the authentication solution route the authentication traffic through the mobile network operator. This, on one hand, it can create higher network traffic, and on the other hand, from a privacy point of view, the MNO can act as a single point of failure. So if the MNO is down, then the users cannot connect to any services. Finally, for the remote SIM provisioning protocol, we believe that creating independent profiles for non-MNO services could be an overkill. For example, having a profile dedicated to Netflix on our device could be an overkill, mainly because that would require all commodity services to have support for, to have their own cellular infrastructure, and also to manage roaming, handover services, etc. So for our idea is to repurpose the SIM technology, eSIM and iSIM, as an authentication utility for a wide range of applications. To do so, we propose some relaxations to the SIM's isolated sandbox. We design a secure provisioning method of dependent profiles. What I mean by dependent here is that we will not have an independent profile per commodity service. However, a profile of an MNO would be required to provision this profile. And these dependent profiles is what we call subprofiles. So to do so, we have to repurpose a little bit the GSMA RSP infrastructure. And finally, we design the whole protocol suite, which we call SIMBA, or SIM-based authentication. So the main novelty here is the concept of a subprofile, and the changes that this brings to the EU ICC, and naturally the protocol suite itself. Now, here's another high-level view of the EU ICC and the changes we propose. These are highlighted with the star. Mainly, we propose the existence of one more component here, the subprofile body, which can be seen as a dual component to ISDR. The main difference here being that while SDR has a network interface, the subprofile body will only have a local interface, and it will act as an intermediate between a mobile app on the user device and the corresponding subprofile inside a main profile ISDP. So concerning the state of the art for authentication, mobile-based authentication, we divide these solutions to two bigger families. The first one, in which the MNO provides the network to carry out the authentication factors, such as SMS-based authentication, and the second family, where MNO provides the authentication factors themselves. And then we have two subfamilies within that family, the one that uses the same credentials for both MNO and non-MNO, and solutions that rely on different credentials, such as, for example, the MSS or Mobi Varmene that we have in Finland. So in our work, the MNO provides the network to provision the authentication factors. We use different credentials for MNO and non-MNO services. And most importantly, in our opinion, the MNO is not involved at all in the authentication process after the provisioning of the credentials. So our protocol consists of 5 different phases: pre-processing, registration, key establishment, authentication and revocation. The pre-processing phase is nothing fancy. We have a non-MNO entity that requests a certificate from a certificate authority and receives back a certificate. So the registration is actually the user registering to a service, could be Netflix, Amazon, or whatever. As a first step, the user and the non-MNO service agree on a subscription plan, and the user provides the commodity service, non-MNO, with its own public key. At this point, the non-MNO service will prepare what we call the subscription data, which, among others, will contain a symmetric key that will eventually be used for authentication. For the key establishment, which is more of a key delivery protocol, this is initiated by the non-MNO service, who contacts the network operator with the subscription data encrypted with the user's public key. So at this point, the MNO knows that a user has a subscription with a non-MNO, but it cannot see the data that have been agreed with the user and the non-MNO, and most importantly, it cannot see the key that was generated by the non-MNO in the previous phase. At this point, MNO initiates a traditional run of the RSP protocol, but instead of ordering a profile, it orders a subprofile for some encrypted data it cannot see, and the SMDB Plus forwards the profile to the user, who decrypts it using its own secret key. And then store the third key in the ECASD component of the EUICC. Now, for the authentication part, here we assume that a user can log in from any client. If the user logs in or tries to log in from its mobile device, then the client and the app is the same entity. So as a first step, the user sends a login request to the non-MNO entity that includes the user ID and the PIN code that is generated locally and on the fly by the client. As a next step, then, non-MNO entity encrypts this PIN code with a third symmetric key and sends it over to the UE, who will forward it to the EUICC with the help of the subprofile body. At this point, the EUICC, the subprofile body, will make all the checks for integrity and freshness of the messages, and if everything is correct, it will output an accept message. And at this point, a pop-up appears on the mobile device that requires the user to type the PIN that was generated in the first step. As a next step, the accept message and the typed PIN will be sent to the non-MNO entity, and if everything is correct, the non-MNO will approve the login request to the client. Finally, for revocation, here we only consider the case where a user wants to end its subscription with the non-MNO entity, and this is initiated by the non-MNO to send a delete request for a specific user to the MNO, and then the MNO initiates again a run of the RSP protocol for updating its own main profile by deleting all the data associated with the non-MNO inside the profile. So concerning the security of the protocol, we have performed a theoretical analysis in which, under the assumptions that the cryptographic primitives that are used satisfy basic security properties, then the confidentiality and integrity of the messages are preserved. And apart from that, we have also performed the formal verification of the protocol by using VerifPal. We demonstrate that no man-in-the-middle attacks or replay attacks are possible in our solution. Finally, for the advantages of our construction, for the users, we believe that it offers minimal user experience. The solution is independent of the user equipment, hardware, and operating system. The only requirement is that the mobile device is eSIM or iSIM compatible. And also it provides passwordless authentication, since the user just needs to type a PIN to log in. a PIN that it's generated fresh on every authentication request. For non-MNO services, we believe that this is a better solution than SMS-based authentication because of security issues with SMS-based authentications, and also it's more cost-effective since in SMS-based authentication the cost is per SMS, while in our solution there are no costs involved. Also, there is a strong binding between the user's EUICC and subscription. That is because the mobile device and the EUICC and the app need to be used as a pair on every authentication request. And it also can help in reducing unauthorized subscription sharing. We do not claim that we make it impossible, we just make it a bit more difficult since the party that holds the subscription need to be in contact with whoever wants to share the service with. Finally, for operators, we see this as a new revenue stream, possibly a new revenue stream, as they can rent out some EUICC space memory to non-MNO services, and also they can charge non-MNOs to use the RSP infrastructure, which does not require significant changes as demonstrated before. And that's all. Thank you.
Okay, thank you. Time for some questions. You'd like to go first?
Yeah, I'll ask a question. Have you spoken to any non-MNOs about your work and what's their opinion?
Not yet, but we are planning to.
Okay.
Like we are discussing with some business groups in Nokia at this point to bring us in contact with some services that could be interested in that.
Yep, Joanna.
Hi, thanks. Why VerifPAL?
Honestly, because it was much easier to use and very user-friendly.
Fair enough.
Yeah, actually, performing a formal verification was a suggestion after the first submission round. So in that short time, we just had to come up with the best we could. Yeah.
And when you said no man-in-the-middle attacks, well, that was, were you specifically, that was your threat model was a man-in-the-middle attack, or is it a more general authentication property?
Well, our threat model was actually modeled after Dolev Yao, in more or less. So we just try to show that no one can tamper with the messages, no one can replay old messages and this kind of attacks. Yeah.
Okay. Any more questions from the audience? Okay. If not, we'll thank Alex again.
Thank you.